Today we'll be going over Chapter 8 in the book of Algebra 2. So we're talking about radical equations. So when we talk about radical equations, we're talking about equations that are completely free of radicals. And those resulting equations are going to be linear equations, which then can be solved for unknown variables. So the directions for equations involving radicals are given over here. So we have to arrange the equations so that the radical term, there's only one, the most complex term, there's more than one, is isolated onto one side of that equation. Then we're going to raise each side of the equation to a power corresponding to the order of the radical and then simplify it. If the equation is not free of radicals, and when we talk about a radical, we're talking about anything underneath the square root sign. Let's look at our first problem here, our first example. We have x minus 5, square root of x minus 5 plus square root of x equals 5. Our first step is going to be to get this, because it is our most complex radical, onto one side of that equation. The easiest way to do this is to subtract square root of x from both sides. So we have x minus 5 plus the square root of x minus the square root of x equals 5 minus the square root of x. So we know that these cancel each other out, leaving us with just this equation here. So now our next step is to now kind of break this all out. So as we learned previously, to rationalize this, all we have to do is multiply it by its opposite. So we're going to multiply this by 5 plus the square root of x. And we just basically FOIL this out, leaving us with square root of x minus 5 equals 25 minus 10 the square root of x plus x. And now we can square this side as well. So if I square this, then the square and the square root basically cancel each other out, leaving me with x minus 5 equals 25 minus 10 square root of x plus x. Simple enough, right? So far we're good. This here is now our largest or our most complex radical, so we need to get it over to this side. So we're going to add it to both sides. So now we have x minus 5 plus 10 to the square root of x equals 25 plus x. And we know that if I subtract x from both sides, they're both going to cancel out. Then I'm going to add 5 to both sides, making this 30. So now my equation all equals 10 square root of x equals 30. From here it's really easy. I'm just going to divide both sides by 10. So this cancels out. Now the square root of x equals 10 goes into 30 3 times. Now I know that if I square both of these, again this and this cancels out, leaving me with x equals 3 squared. 3 squared is 9. And there's my answer. Now I can check this by plugging it into my equation again. So, square root of x minus 5 plus the square root of x equals 5. So remember we said that x equaled 9. So let's put that in. So now we have 9 minus 5 plus the square root of 9 equals 5. Well, 9 minus 5, that's easy, it's 4. plus the square root of 9 equals 5. Well, 4 squared is 2, plus the square root of 9 is 3. 3 plus 2 is 5. And our answer checks. Let's look at our next problem. So next problem is the square root of x minus 7 minus the square root of x equals 7. So we're going to do the same thing. We want to make this on one side of the equation, so we're going to add the square root of x to both sides. So I have square root of x minus 7 plus and minus that equals 7 minus square root plus the square root of x. Because remember, I'm adding it to both sides this time and not subtracting it. So those are going to cancel out. Alright, so now, again, we're going to multiply this by its opposite. I've FOILed that, leaving us with the square root of x minus 7 equals 49 plus 14 square root of x plus x. And now I'm going to square this again. Alright, so now again we're going to move this one to the other side as it's our largest and most complex radical at the moment. So we're going to subtract it from both sides. So we have x minus 7 minus 14 square root of x equals 49 plus x. And as we saw previously, if I subtract x from both sides, they're both going to cancel out. I'm going to add 7 to both sides. So that cancels that out, and this makes this a 56. So now I have negative 14 square root of x equals 56. Now, this negative, I really want to get rid of on this side, as it's not being very helpful to us at the moment. So I'm going to multiply the whole thing, multiply all of this by 1. And that's going to make this positive 14, and this the negative 56. And that's a lot easier for me to be able to do. Because now when I divide 14 by both sides, I can get square root of x equals negative 4. And when I square both of these, I get that x equals 16. So let's plug our answer into our equation and see if it checks out. So square root of x minus 7 minus the square root of x equals 7. And again, x is equal to 16 according to what we did. So 16 minus 7, 16. So 16 minus 7, square root 9 minus square root 16. So 9 square root is 3 minus 4. That equals negative 1 though, so they do not check out. So the value of x obtained here does not satisfy the original equation and thus is an extraneous root. So the answer to this is actually no solution, or 0. This is going to be more important later on when we get to invisible numbers, which I know is big and scary right now, but it'll make a lot more sense later on. So if it does not equal, it means it's extraneous root and it's no solution. Simple as that.